In this video, we're going to talk about substitution methods for differential equations. And so the problem that I want to start with is let's solve the differential equation y prime, or let's say dy dx is equal to x plus y plus 3 squared. So the square makes it so that it's not a linear problem. It's not separable, of course. It wouldn't be separable with or without the square. And this is the problem that we're faced with. Now, of course, the fact that I said that we're going to talk about substitution leads us to the idea that maybe we can substitute u is x plus y plus 3. And so that's exactly what we're going to do. So we're going to make a substitution just like we would do when we're trying to evaluate integrals in Calc 1 and Calc 2 and Calc 3 for that matter. The difference here is that if we let u be a function of x and y, then when we talk about derivatives, we're going to have to talk about partial derivatives, at least in general. For this one, everything actually works out just fine. I'll talk about how this works in general in the next video, but for this one, du dx is just, if we differentiate each term with respect to x, we're going to end up with 1 plus dy dx plus 0. So that's going to be our du dx. So this means that dy dx is going to become du dx minus 1. And the right side is going to become u squared. And therefore, du dx is going to be u squared plus 1. And now this is separable. We can solve it. Everything is fine. So that implies. So this implies that 1 over u squared plus 1 du is equal to dx. And then we integrate both sides just like we would for any separable differential equation. The integral of the left-hand side is inverse tangent. So this is inverse tangent of u. The integral of the right-hand side is, of course, just x plus c. And then what we can do is we're going to try and get y by itself now. So what we're going to have to do first is get u by itself, and then remember what our substitution was to begin with. So we're going to end up with u being tangent of x plus c. And then u was x plus y plus 3. So that's going to be tangent of x plus c. In other words, y, our solution, is going to end up being tangent of x plus c minus x minus 3. And then you can, I'll leave it to you to actually check and go through and make sure that the derivative really does satisfy what we have. But this in general is substitution. Okay, so the idea is that you substitute some function. We'll have to use the Calc 3, the multivariate chain rule, in order to figure out how this works in general, but we'll talk about that in the next video.